Hello. What I'm going to do is go through some pre-calc trig examples with you. So let me just walk you through this. This is going to cover a few sections of material. We'll go through solving right triangles for missing angles and sides. And this will be using sine, cosine, tangent, and the inverses. We'll go through a couple story problems involving angle of elevation and depression. Go through some special right triangle rules for 30, 60, 90 triangles and 45, 45, 90 triangles. And then we'll do some conversions as far as the degrees, minutes, and seconds go, and vice versa. And then we'll finish them off with coterminal angle measures and reference angles in a coordinate plane. A lot of fun stuff. Alright, so I'm going to get rolling with just solving right triangles. So I have right triangle ABC here. What I want to do when it says solve it is basically figure out what my angle measures are and my missing side. So in this case, I'm going to be solving for the little b. And then the A, the capital letter A standing for the angle measure here, and then capital B for this angle. So the first thing that I could do right away is the Pythagorean theorem and figure out what my missing side length is, which is B in this case. So I know two of my three sides. So Pythagorean theorem is what we're going to use to figure out the the length of our third side. So I'm going to set this up as 35 squared plus B squared equals 42 squared. And the 35 and the b are the legs of it. So this is 1225 plus b squared equals 42 squared, which is 1764. I'm going to subtract 1225 on both sides, and that's going to give me 539. And then I can take the square root of that to figure out what b is. And I'm going to round all these to the nearest tenth. So this will be 23.2, and that would be inches. So that's what my b value is. And now I want to figure out what my angle measures are. So I'm going to have to use inverse trig functions here. I'm going to start by figuring out what A is first. And what you want to do is identify what your reference angle is, and then identify what the sides are compared to this reference angle. So I'm going to call my 35 my opposite side, since it's across from angle A. And then the side that is across from the right angle in the triangle is going to be my hypotenuse. So I need to go through and figure out between sine, cosine, and tangent what I'm going to use for a trig function, and which one of these is going to use opposite and hypotenuse, and that will be the sine function. So we set up our ratio by saying, okay, the sine of A, that ratio of opposite to adjacent or opposite to hypotenuse is 35 over 42, and then to get A by itself, I'm going to need to use inverse trig functions to basically undo the fact that I have a sine here. So A is going to equal what's called sine inverse, also known as arcsine. So this means the same thing as sine inverse. So it would be arcsine or sine inverse of 35 over 42. And in a calculator, which you're going to do then, and I'll kind of pull this up. Oops. So what I'll do within the calculator, oh my goodness, okay, is press second and then sine, and then you can just type in 35 divided by 42. Before I hit enter on this, I'm going to just hit mode and make sure my calculator is in the right measure. I'm going to have to move it over to degree. So I pressed mode and I want to move my calculator over to degree, and now I'll actually get a right answer here. So now I can hit enter, and my angle measure is 56.4 degrees. So just going back to this diagram then, so I already know that this side is 23.2 inches. This angle is 56.4, so now I just want to figure out what angle B is. And I don't even need any trig to do that. Basically, you know that the triangle sum theorem is what tells us all the interior angles of a triangle sum to 180. I'm always going to have a right angle in a right triangle, so that means that these two angles are your complementary angles. These are going to add up to 90. So if I want to figure out what the measure of angle B is, I'm just going to take 90 minus 56.4. And again, you could have used trig and actually figured out what this is, but this also works. Again, this is kind of a little bit shorter. Just taking 90 minus 56.4 gives me an angle measure of 33.6 degrees. On to the next one. So with this one, we're going to figure out two missing sides here, and then I'm also going to figure out a missing angle. So I'm going to just go ahead and figure out what the measure of angle D is, exactly how we left off on the last example. Angle D and angle F are complementary angles. which means they're going to add up to 90. So if I just take 90 minus 56, I'm going to get 34 degrees. And that's automatically just going to be what D is then. So that's a lot easier, I'd say, to do for a first step then. So what I'm going to do now is figure out what the measure of both of these sides are. I'm going to refer to, I'll just refer to this as F, and I will refer to this as my lowercase e. And what I want to do is use my 12.3, and I'm going to use my 56 and figure out what these measurements are. So from 56, and I'll solve for F first, F is my opposite side, and 12.3 is my adjacent side. 12.3 is not my hypotenuse, it's not across from the right angle. However, it is next to my 56 degrees, and that's what adjacent means. So if I'm going to be using my opposite and adjacent, that means I'm going to be using my tangent function. So tan 56 equals F over 12.3. So in order to isolate the F, right now it's being divided by 12.3, so I'm going to multiply both sides by 12.3. So F is going to equal 12.3 times the tangent of 56. And you can throw that in your calculator, 12.3 tan 56, and I'm getting 18.2, and that would be centimeters. So F is 18.2. And lastly, again, I can now do the Pythagorean theorem if I wanted to figure out what E is. I'm going to actually do it using trigonometry just to get this practice and show you another example of this. So I'm going to kind of just wipe this diagram except for the side E here, which is my missing side, and I'm going to go through an example where I'm going to use my adjacent side and my hypotenuse, which is my cosine function, and I primarily want to do this just to show what happens when my variable will be in the denominator. So in this case, when I write this out, the cosine of 56 degrees, which is the adjacent side over the hypotenuse, notice I have a variable in my denominator. What I can do is really just flip-flop these two values and say that E equals 12.3 divided by cosine of 56. So that's how we're going to isolate our variable in this case. And I'll take 12.3 divided by cosine of 56, and I'm getting 21.999. Okay, so we're going to call this 22 centimeters. And that is all for that problem then. So I had my missing sides and my angles. And like I said, what I could do just to verify this is take 12.3 squared plus 18.2 squared, and that would also have gotten my E squared. So again, this is the Pythagorean theorem if you wanted to do that to figure out what E is. And again, I just use trig. Both of those options will give you the same answer of about 22 centimeters. So now we'll do a couple of the applications with these. Brad is constructing a ramp at his house. He is positioning the board so that it is 8 feet from the house and plans to use either a 3-degree angle of elevation or 4 degrees. So we'll take a look at what that little 1 degree difference does in terms of height. And I'm going to make it look like it's a really dramatic difference here. So this one on the right hand side would be a greater incline than the one on the left. So the first thing that I'm noticing when I go through this, it says what is the height difference in the ramps, and then we're going to express our answer in inches, is I have inches and feet here. So he is positioning the board first of all so that it's 8 feet from the house. We're not saying that the board is 8 feet long, we're saying that it's positioned, so this value across the bottom here is 8 feet, which I'm also going to write then, if I were to multiply that by 12 to convert it to inches, that would be 96 inches. And that same thing would go over here, 8 feet is 96 inches, and again it's leaning up against his house. So what we want to also look at is that it's a 3-degree angle of elevation. So that's going to be this little angle here as it's tilting up from the ground. This is 3 degrees, and in this example it is 4 degrees. And we want to look at the height difference. So again, I'm not looking at the length of the ramp. I'm instead looking at this value, which would be lower than or less than this value. So if you think about it, the greater this angle is, the higher up the ramp is going to be. You would not expect to see like a 60-degree incline or something on a ramp. That would be just completely chaotic. So we're talking about a very small difference, but you'll see it'll be a few degrees difference in the height, I believe, of the overall ramp. So we're going to do some trig here and figure out from my reference angle, which will be 3 degrees, what I'm going to name these sides. And notice that across from my 90, or my right angle here, is the hypotenuse, and I have nothing to do with that. I don't really care about the length of the board in these situations. I'm really looking at my opposite and my adjacent side from the 3 degrees. So that implies I'm going to use tangent. So I'm going to say tan 3 equals my opposite side, which is x, over my adjacent side, which I'm going to use 96. And again, the reason for this is that we are expressing our answer in inches, and I just don't want to convert it later than, which we could though. If you had this over 8, you would just need to convert your answer later from feet into inches. So I just decided to do that right away at the beginning of the problem. And I'm going to do the same thing for the one on this right hand side. The only difference is my reference angle is now 4 degrees. So if I want to solve these, just to isolate the x's and y's, I'm going to bring the 96 over by multiplying in both those cases. So 96 times the tangent of 3, and y is going to equal 96 times the tangent of 4. So I'm going to throw this in the calculator. 96 tan 3 is going to give me a height of 5.03 inches. And then right here, so that's my x value. And then right here for my y value, I'll do the same thing. Take 96 times tan 4, and that height is 6.71 inches. So again, the ramp that's on the right-hand side is higher than the one that's on the left because that angle measure is a little bit larger. So the last thing I want to do here, it says what is the height difference in the ramps? I need to basically take y minus x, which is going to be finding the difference between these two ramps. So I'm going to do my 6.71 and subtract 5.03 and get a difference of 1.68 inches. And that is all. So that is one of those examples where I'm using the terms angle of elevation a couple times in here, and noticing again, if I had a greater angle of elevation, I would have a higher ramp. The next one is going to be a similar problem where it says Chris and Donna are in a building and they're in different floors waving at their friend Leslie, who is standing 75 feet from the building. So I'm going to go ahead and say, okay, this is the building. I'm going to just put, let's say this is Chris right here. This is a little dot, that's Chris. And Donna is going to be up here. And it says the distance, oh yeah, and Leslie is down here. Now she's standing away from the building. And we do know that height. It says that she is 75 feet from the building, and that's going to be this distance right here, is 75 feet. And it says that the distance from Leslie to Chris is 128 feet. So this is little Leslie down here. The distance from her to Chris, so that's going to be just going straight over, and that distance is 128 feet. And then the distance from her to Donna is going to be 156 feet. So that's going to be just looking straight up here, and that's 156 feet. So what I have is basically two right triangles. So I'm going to redraw these off to the side, and this is going to be the one that's going to represent the one for Chris, and I'll do one a little bit larger representing the one that is used to figure out how far she is, or what the angle is from Donna. And what we're going to do next then, or I guess I should label these. So this is my right angle formed between the buildings. So here's Leslie in each of these cases. Here's going to be Donna. Here's going to be Chris. And again, this is 75, and up here was 128. And then she was 156 feet away from Donna. And again, 75 from the building. So what we want to do is look at how much greater is the angle of elevation between these two. So I'm going to be solving for this value here. So I'm going to be looking at not my opposite side, which is basically saying I don't care how much higher up on the building one is than the other. We're going to be focusing on the angle of elevation in both of these cases. So in this first one, I'm going to call it x, and in the second one, I'll call it y. And what's nice again about this is we're going to use the same trig function for both of these. I'm going to be dealing with my adjacent side and my hypotenuse, which indicates that I will be using cosine of x as 75 over 128. And then I'll do the same thing here and say cosine of y is going to be 75 over 156. So we're going to look at the fact that with the one on the right, since she is looking at her from a further distance, that must mean that she's looking up higher. So that means that that angle is going to be a greater measure. So the next thing I'm going to do is write out that In order to get x by itself, I'm going to need to use my inverse function. So inverse cosine of 75 over 128. And then same thing here for y. It's going to be cosine inverse, or we could again call it arc cosine. It's the same thing. And then all that you have to do in the calculator then is press second and then cosine 75 divided by 128. And I'm getting an angle measure of 54.13 degrees. And then for y, I'm going to do the same thing, second and then cosine, and that's 75 divided by 156. And that one's going to come out to 61.26 degrees. So at the very end of this, again, the question is saying how much greater is the angle of elevation. So much like the last problem, I'm going to be subtracting my values at the end here and take 61.26 minus 54.13 to subtract these two values and figure out that the difference between the angles of elevation is 7.13 degrees. So she's looking up just a little bit more. Alright, next problems. So we're kind of switching gears here. We're going to just look at some 45-45-90 triangles and 30-60-90 triangles, which are just a couple special cases of right triangles. I'll go over the rules really quick on another slide. In a 45-45-90, you have two congruent legs and you have a hypotenuse. So if my legs are both called x, my hypotenuse is roughly 1.4 times the length of this, which we're going to be calling the square root of 2. So if I know what my leg is, I can just multiply by the square root of 2 and get my hypotenuse. In a 30-60-90 triangle, I have a short leg, which is across from my 30. I have a long leg, which is across from my 60. And that one is radical 3 times the length of the short. And then I have a hypotenuse, which is across from my right angle, and that's going to be double the length of the short leg. So these are going to be the rules for both of the triangles. So if you want to pause, take down those notes. So the first two examples, or three examples I'll go through then will be 45-45-90. So you just want to look if you're given a leg or a hypotenuse in these. So in this first one, I'm going to be given a leg, and I know this because it's not across from the right angle here. So that automatically means, because it's a special right triangle of 45-45-90, that my x value here is going to be 3. And then, again, in order to get your hypotenuse, you are going from my leg to my hypotenuse. It is radical 2 times the size. So that's it. That is the simplest radical form that we're asking for. In this next one, notice I'm going to be starting with my hypotenuse because it's across from the right angle. And my hypotenuse is radical 2 times the length of these two short legs here. So what I'm going to need to do is divide by the square root of 2. This is going to cancel out, and I'll be left with 5, and that is going to be both of x and y. Alright, next one, I'm going to be given a leg of 5 radical 2 instead of a hypotenuse. So this will be a little bit different. First of all, it's a leg, because it is not across from the 90 here. So what I'm going to do is just automatically fill in that y is also going to be 5 radical 2. Again, reason being is that your legs are congruent. So to go from leg to hypotenuse, so I want to figure out this x value, I'm going to take the length of my side, and I need to multiply it by the square root of 2. Again, the hypotenuse is radical 2 times the length of the short leg. So the radical 2 times radical 2 is really the square root of 4, which is 2. So I really have 5 times 2 here. So my x value, which again is the hypotenuse, is 10. We'll take a look then at some 30-60-90 problems. So I have 4 of these examples, I believe. So in this first one, again, you want to identify what you're starting with. In this case, I'm starting with my short leg. I know that this is my short leg because it's across from the smallest angle, which is 30. So I'm going to go from short leg to hypotenuse, which is double the length. It's not radical 2 times the length. Your hypotenuse is just double the length of the short leg. So 14 is my hypotenuse. And then my long leg is radical 3 times the length of my short leg. So that means that my x value here is just 7 radical 3. And that's it. Nothing really fancy you have to do there. The next one will actually be kind of short like that too. So there's nothing we have to do as far as rationalizing denominators or taking out perfect squares or anything. In this next one, notice I'm starting with the side that is across from my right angle. So this is my hypotenuse. And the only thing that I can really do first is go from hypotenuse to short leg. And again, this y value is exactly half as much as my hypotenuse, so y is going to be 4. And then again, much like the last problem, in order to get my long leg, if I know my short leg, I'm just going to multiply by the square root of 3. So again, your long leg is radical 3 times the length of the short leg. 2 more examples then. With this next one, I'm going to be starting with a long leg. I know this because it's across from the 60-degree angle. So what I'm going to do is be able to go from long to short. So my long leg is radical 3 times the length of the short leg. So I'm going to need to divide by the square root of 3. And I'm going to end up with a short leg of 9. So I know what my short leg is, and I know what my long leg is. And I want to figure out my hypotenuse, so I just double the short leg, and I get a y value of 18. And then in this last one, I'm given the hypotenuse, so again, it's across from the right angle here. So what I'm going to do first is get my short leg. So I'm going to take this hypotenuse, which is double what my short leg is, and I'm going to divide by 2. So the 16 over the 2 means that my short leg then is going to be 8 times the square root of 3, so it's half as much there. So that part I think is the easier part. Now getting the getting the long leg, I'm going to go from short to long. This long leg is radical 3 times the length of the short leg. So I'm going to take 8 radical 3, and I need to multiply that by radical 3. So this part right here, radical 3 times radical 3 is just 3. So in this problem, my long leg is going to be 24. Alright, and now we're going to go on to some of these conversions between basically like a decimal form of an angle measure, and we're going to convert it into what's called degrees, minutes, and seconds. So how this works, it's just like how 60 seconds make up a minute and 60 minutes make up an hour. We're going to use that same kind of logic to rewrite this decimal part. So what you do is you keep the whole number part as 52 degrees. What I do then is I go to the calculator and I put in the decimal part, 0.465. And what I want to do is figure out how many minutes and seconds this is. So I just multiply by 60, and that's going to give me 27.9 minutes. So I write the whole number part here, and I put the 1 dash representing minutes. Now I take this decimal. So this decimal is 0.9, and I want to take that and multiply it by 60 to figure out how many seconds I have. And that is 54. So what I really end up with, and these are just the same exact way of expressing the same angle, 52.465 degrees is the same thing if I say 52 degrees, 27 minutes, and 54 seconds. You're just breaking apart that decimal part and expressing it in terms of how many minutes or seconds it is, which is again out of 60. So the next one, the only difference is it's a negative, which doesn't change much. The big idea here again is my whole number value here is the negative 137 degrees. What I'm going to do is throw the decimal part into my calculator, 0.186, and I want to first figure out how many minutes that is. So I multiply it by 60, and that's going to give me 11 minutes. And then I look at that decimal part, which again, that's the 0.16, so I'll put the 0.16 in my calculator now, and I will multiply that by 60. And that's going to tell me how many seconds. And what I'm going to do here is round appropriately up or down. In this case, I'm going to round up to 10, so it would be 10 seconds then. So I would say negative 137 degrees, 11 minutes, 10 seconds. So we're going to do these conversions now, but working backwards. So I'm going to start with a couple angle measures and show you how to put this into your calculator in one shot. So what I'm going to do is just realize, first of all, again, the negative 44 is going to be the part that's before the decimal. Just like in this next one, the 165 will be the part that's before the decimal. So I want to figure out what 27 minutes and 35 seconds is. So what I'm going to do is say, okay, well 27 is a fraction of 60, and to that I'm going to add the 35 seconds. Now this is the part that's a little bit weird. The 35 is technically over a 60th of a 60th, which is a 3600th. If you were to take a 60th times a 60th, you would get 3600. Now, I hit enter, and this again just represents the decimal part of my answer, which I'm going to round to 3 decimal spots. So instead of writing it as what it is, I'm going to be rounding this 9 up. So my answer, even though it's only going to look like 2 decimals, technically will be 3. I will say 0.46. And again, that is basically the conversion backwards into a decimal degree. And I'll do the same thing here. I'm going to do a parenthesis. I'm going to put 48 divided by 60. I'm going to close the parenthesis and then plus, and I'll do 19 divided by 3600. Which again, the 3600 is coming from the fact that that is a 60th of a 60th, and that's going to give me 0.805. So again, that's going to be the decimal part of my answer. The rest of that is going to stay the same. Alright, on to the last problems. So with these, it's going to say determine the measure of a coterminal angle between 0 and 360 degrees. We're going to identify the quadrant of the terminal side, and we're going to state the measure of a reference angle. So there's a lot that's going to go on in these problems. So first thing I want to do is explain what a coterminal angle is. For example, if I have an angle measure of, let's say, 30 degrees. 30 degrees looks something like this. If I were to take a full lap around my circle and then go to 30, think about what that would be. If I were to go a full lap around, that's 360 degrees, plus another 30 more means 390 degrees, which what I want you to understand is these two angle measures are going to look the exact same in the coordinate plane. They're both going to look like this as far as where the terminal side goes. So again, that's basically taking a full lap around is 360 degrees, plus that 30. Again, the word that we would use to represent this is coterminal. These angles are coterminal angles. This would be your first quadrant, this is your second quadrant, this is your third quadrant, and then this is your fourth quadrant. So the other thing to mention is let's say I have an angle that's on the other side of the coordinate plane. Let's say I had an angle that was 160 degrees. If I went over 160, I would be over here somewhere. I wouldn't quite be to my 180. So when I want to figure out what my reference angle is, I just need to see how much more I need to get to 180. So if you just take 180 minus 160, my reference angle would be 20. So that's what we're talking about with reference angle, is saying how much more or less would you really need to get back to the x-axis. And that's what we're going to do in this first example. So what I'm going to do, and I'll do this in the calculator, 456 degrees definitely means I'd be going around the circle more than one time. So I'm going to take my 456 and divide by 360 degrees. What this is going to tell me is that I am going around the circle 1.26 times. Okay, so I know a full circle is 360. So what I'm going to do is just take the decimal part of that. So I'm going to subtract off my whole number part, which is 1, and this gives me the decimal part. So I want to figure out, okay, we're going a full circle plus this 0.26 repeating value. I want to figure out how many degrees that is. So I'm going to multiply it by how many degrees are in a full circle, which is 360. And that's going to give me 96 degrees. So what I'm doing is I'm going a full circle plus 96 more degrees. And you know that this would be 90, so I'm going to be going a little bit past that. So if I were to draw this now, I'm really going to end up with a side that's going to be up here where that ends. And again, we refer to this as my terminal side. Okay? So we knew that this would represent the 96 degrees that we went past 360. And in order to figure out what my reference angle is, I'm going to go straight down to the x-axis. This is in quadrant 2, by the way. And we want to figure out what this remaining angle measure would be. So what I'm going to do is just look at how much more I would need. This whole area right here is 90 degrees. But what I could do is just realize, okay, if this is 96, I want to figure out how much more I need to get to 180. I'm just going to take 180 minus 96. And what that's going to do is tell me how much my reference angle is going to be, which is this angle measure right here, and that is 84 degrees. So we'll do a couple more of these examples because it seemed kind of confusing. I'm going to actually save the negative one for last. Let's do this one next. 654 degrees. And again, I'm going to follow the same process. I'm going to first figure out how many times am I going around the circle, which means I'm going to divide. I'm going to take 654 divided by 360, and that says, okay, I'm going 1.816 times around my circle. Well, I know a full circle is the 360. So again, I'm going to subtract off the whole number part of this, and I want to know how many degrees 0.816 of a circle is. So I multiply it by 360. And that says, hey, we're going 294 total degrees out of 360. So I want to know where 294 lies, which again, all the way up to here is 270. So we're going past 270 all the way up to 294, wherever that's going to end up. So that's all the way around the circle going this way. Again, we're going to be solving for this reference angle, which this is all in quadrant 4. Okay, oops. There we go. Okay, so this is all in quadrant 4. And what I want to do is figure out what this reference angle is. So I need to know how much more am I going to need to get to 360, which again, all that you have to do now is take 360 minus 294. And that's going to give me this reference angle right here, which is 66 degrees. So I'm going to go back now and look at a difference, which is when I have a negative angle. But again, we're going to start this off the same way. It just means that we would be moving clockwise. So I'm going to start by taking negative 1251, and I'm going to divide by 360. And again, the point of doing this is to figure out how many times this is wrapping around my circle. So this is going a full 3.475 times. So what this means is I'm going around the circle once, I'm going around the circle again, and then I'm going around the circle again, and then I have this leftover part. I'm going around the circle 0.475 times, so it's not quite another half a circle. So I know that I'm going to end up down here somewhere. So what I'm going to do to figure out how many degrees that is subtract my whole number part. So I'm really just going to look at the 0.475 then, and I want to multiply that by 360. Which again, that represents how many more degrees is this part. So it's 171 total degrees more. So think about this. I'm going a full 3 times around, and then another 171 degrees. So that tells me that my terminal side here is going to be in quadrant 3. Again, this was 171 degrees. Wait, was it 171? Yeah, okay, 171 degrees, which is not quite to the 180. So in order to figure out what my reference angle is, I need to figure out how much more do I need from 171 to get to 180, and that's going to end up being 9 degrees, which again, I could just take 180 minus 171, and that gives me a reference angle then of 9 degrees. So just taking a look again, those were the last few problems, was dealing with coterminal and terminal angles, terminal sides, I mean. We had the conversions with the degrees, minutes, seconds, the special right triangles, and then some sine, cosine, tangent problems.